Anytime you solve radical equations, it's often convenient to isolate one of the radicals. And so in this case, we want to subtract the 3 to the other side. This will give us the square root of 2n plus 29 is equal to n minus 3. We can then square each side, and that will lift off the radical on the left, leaving us with 2n plus 29. And on the right, we're going to have n minus 3 times itself, which is n squared minus 6n plus 9. This is a quadratic equation in n, and we want to set it equal to 0. So I'm going to bring the terms from the left over to the right, and that means I need to subtract 2n and subtract 29 on each side. We now have n squared minus 8n minus 20 on the right-hand side of the equation. This will factor into n minus 10 times n plus 2, and n appears to equal 10 or negative 2. When we take that negative 2 and substitute it back in, however, we get a positive value plus 3 equals negative 2, and that negative 2 will not work, and our sole value in the solution set is 10. And it does check if you took the time to check it. Solve this next problem. We have two radicals in it, and we want to isolate one on the left and put the other to the other side. So I'm going to leave the square root of d plus 4 on the left and bring the square root of 6 plus 2d to the right, followed by the minus 1. I now want to lift off these radicals if I can by squaring both sides. The left side is easy to square. It becomes d plus 4. The right-hand side is a little bit more challenging, and it's often easier if we rewrite it as a product. Square root of 6d, 6 plus 2d minus 1 times itself. The left side has no change. When we go to multiply the right side, the first term of FOIL is 6 plus 2d. We then have minus radical and minus radical, making minus 2 roots of 6 plus 2d, and the L term of FOIL is plus 1. Okay, we need to do a little bit of work here. We see a 7 on the right-hand side. We're going to subtract it off of each side. I'm also going to subtract off 2d. This is going to leave us negative d minus 3 equals negative 2 square roots of 6 plus 2d. I don't want to divide through by negative 2 because then we're going to create a fraction on the left. But I do want to have positive numbers. So let's multiply through by negative 1 and get d plus 3 equals 2 times the square root of 6 plus 2d. Foiling the left-hand side, we have d squared plus 6d plus 9. And multiplying the right side by itself, we have 4 times the quantity, 6 plus 2d. Okay, no changes can be made on the left. I'm just going to bring those terms down. And on the right, we have some distribution, 24 plus 8d. Let's bring these to the left and subtract them off. We're going to have d squared minus 2d minus 15 is equal to 0. This will then factor into d minus 5 times d plus 3 equals 0, and d will either equal 5 or negative 3. It turns out that both of these values work when you substitute them in, so those two values go into the solution set. That was a long problem. In this next problem, we have a fractional exponent, which is probably not something you're used to working with as much. But when you have a fractional exponent, the numerator refers to the power. And in this case, we're talking about a cube. And the denominator of the fractional exponent, or rational exponent, refers to the type of root we're dealing with here. And so we have a fourth root. And we want to undo this rational exponent. We're going to begin by dividing each side of this equation by 4. because that exponent is not applied to that coefficient out front. So we now have y minus 3 to the 3/4 power is equal to 5. Now the easiest way to get rid of this rational exponent is to raise each side to the reciprocal power. And the reciprocal of 3/4 is 4/3. Now, when you raise a power to a power, you multiply exponents, and when you multiply reciprocals, the product is 1. So basically, the left side becomes y minus 3 to the first power, or just y minus 3, is equal to 5 to the 4/3 power. And adding 3 to each side, we get y is equal to 5 to the 4/3 power plus 3. Written as a solution set, our solution set would contain 5 to the 4/3 power plus 3.